Hello, Korea. How are you doing? I'm very happy to meet you all. Hope you're all having a fantastic day at JSConf Korea. First of all, I want to thank all the organizers of this conference for all the hard work they've put in to make this conference possible despite the current global circumstances. Unfortunately, I can't be there in person, but I'm so happy that I can reach out to you all in this medium. I'm here to talk about how we can make the life of our developers much easier who work on large monorepos. A monorepo or a monorepository is a single repository that stores all of your code and assets for every project. We will look at JavaScript monorepo throughout this talk. In the beginning, we will try to understand what are some of the reasons why we opted for like a monorepo structure for our code. Then we look at some of the tooling and techniques which can help you be more productive with monorepos. I am Jay Santhosh, and I work as an engineering manager at Microsoft. I'm available on Twitter, and my handle is at JSanth. I'm from this beautiful city of Bangalore in South India. Usually, the traffic is much more than what you can see in that illustration. At Microsoft, I work on a product called Microsoft Search, where we build unified search experiences for like all your work related content across Microsoft 365 App Suite, Windows, and Bing. When you look at the search product, you can see that there are multiple components like the search box, the search results page, and a lot of other components which are shared across the products so that we can achieve a uniform experience for the end user across the products. Experiences like search are what we consider as high value experiences, which are critical operations a user does across applications and across platforms in the Office suite. We also need to be more coherent to ensure the search experiences also look consistent with the rest of the application and across various apps and platforms. We have over 400 developers who work on this monorepo. We also integrate the components we develop across the Microsoft products like Office, SharePoint, Teams, etc. And we mainly call these as host apps. Let's take the example of a simpler high-value experience like the people card. The people card started out as a simpler contact information card. Over time, this has started growing in complexity. So now you can see that it has evolved in how it looks like and how much more feature rich it has become. Let us understand it in a bit more detail. You can see here that the people card now consists of various sections such as insights. It contains recent activity, conversations, shared documents between you and the other person. What are the upcoming events between you two, and a lot more apart from the contact information of the user. So it has actually evolved and grown in intelligence as well as how much information it actually contains. Also, each section is actually expanded into even more detailed components, which are much more complex in nature. Here you can see that there are very like deeper conversations components that you can see. The contact information is also much more zoomed out uh, and zoomed in. I, like you can have like documents between the two people that you have that you've shared or like that you have access to. You can have access to all the events that are upcoming or the ones that you've recently had. The organization chart information for you, especially in a large company, is really useful. And you also have a lot more analytics and insights that you can get, right? So the people card now ended up having more than 20 categories of information. Now let's look at what we do as a developer when we're developing something like a people card. If we visualize our agility, we can see it is something like this. We can break it into two loops, the inner loop and the outer loop. The inner loop is more of a daily routine where you write new code, test it locally, create a pull request, verify build and test reports, and merge it with the main branch. The outer loop consists of actions after the code is checked in, right? So we deploy it through different range to production, listen and measure feedback, propose what are the next steps to improve a feature or a certain component, and then write code and go back to inner loop again, right? So now if you just zoom out a bit, you can see that how we can map this in practice for the people card scenario. Here, the outer loop is actually much more diverse, right? So it is more than any one given platform. So scaling out is really necessary, which works across the various platforms. We actually developed to 6 platforms as shown here, like the web, the iOS, UWP, Mac OS, Win32, and so on. In most cases, the usual norm is that each platform is typically siloed for their UX and development based on code base and people. Uh, Working across teams is very hard. It does scatter your developer environment. Cross repo changes or rollback is very hard. It is very difficult to enforce conventions across different repos. Apart from all the software aspects, the largest problem is to tackle, the people aspect. So we are working with, as I said, more than 400 developers across various teams, and all of these people may not buy into the same goals. Hence, we looked at unifying the code bases into a single source repository and evaluate if it can improve the developer agility. To summarize, the people card now has to be shared across multiple applications or host apps that we call in the Office 365 suite, as well as across 6 platforms in a cohesive way where the people card still remains people card, but still has similar behavior and kind of looks homogeneous within each of these host apps, and also kind of brings in native usage and interactability patterns into the people to the same component. So we need to find a way to maximize developer agility here. We started adding all of this code to one single repository or a monorepo, and this brought in more singularity across packages. Now, let's look at what is a monorepo, right? A monorepo is a repository with multiple packages or projects. It need not necessarily be a colossal 86 terabyte monolith, but somewhere where various projects and packages can coexist. It also allows us to break our code down to packages with single responsibility, and hence multiple packages which are aggregated this way can help in ensuring that even in other repository or the host app repository, they can actually pick a certain package and just use it. For example, think of the people card being used in a calendar widget in Outlook, right? So this way, it actually allows reuse of small packages across multiple host apps and other repositories. Having all of this in a single repo also helped us unify processes across packages, make developers more agile, achieve more code consistency. So even for new developers who joined the team, it was very easy for them to discover code across the packages. And that way it was helpful to have things in one place rather than scattered in multiple repositories. For our work on People Card, it looks something like this. One thing we focused on was to ensure we break all the code down to smaller packages, which had single responsibility. This way, we were able to achieve maximum reuse across platforms. For example, here we broke the People Card down into people data, people auth, people core, which can then be shared centrally across platform-specific packages like people web, people iOS, and so on. So moving to a monorepo meant that we absolutely need to nail and have reliable tooling across various categories like package management, cross-package orchestration, linting, testing tools, build systems, infrastructure, and much more. In this talk, we'll mainly look at 2 of the hardest problems of package management and cross-package orchestrators. These are some things that are very basic in the essence of a monorepo and something where we might end up spending a lot more time and lose our productivity, right? Let's understand how we can simplify package management now in a JavaScript monorepo. So JavaScript packages are the building blocks of any large JavaScript repo. The repository that we work in has over 150 to 200 internal packages. We take a dependency of over 2,500 external packages. For our components to work well with each other and with our partner repos, we really need to manage our packages really well. Before we learn more about it, let us first understand how a package gets used. The package.json file is actually read by the package managers such as npm or yarn. When you require a certain module in your JavaScript file, Node.js will resolve this by looking at the module on disk. Right? So the package manager actually writes files to disk, which then your Node.js process kind of looks at the files that are on the disk. So the key insight here is that Node will not resolve anything by looking at the package.json, but rather it will just look at the file with node module resolution, which is present on the disk. It won't even verify that if it is getting the right version that is required or not, right? So we need to just ensure that the files on disk are actually proper, and that's where Node can pick it up from. So node module resolution is a key concept in Node.js. The basic idea behind this algorithm is that it recursively looks at for a certain package that is required. Let's take an example. Say if a module in the people core package depends on React, Node will look for it in the React in the node modules folder of people core. If it can't find it there, it will look in the node modules folder of the parent of people core, and so on all the way to the root of your hard drive, right? So now let's map this concept in case of a monorepo. Assume that we have two repositories with package one and package two. With a monorepo, you can see that like both of these packages come to the same folder under a monorepo, right? We want to look at a few issues with Monorepo, which probably we can solve with our current understanding of how Node resolves modules, right? A concept package managers use is sharing common dependencies on disk. Because of the nature of Monorepo, most packages will share many dependencies, and there can also be, like some packages can be dependent on other packages within the Monorepo itself. So imagine having two packages, like I said, package one and package two. We have three dependencies here on package B, and then we have where we have two versions. So say package one depends on packages A, C, and then A internally takes a dependency on B of 1.0 version. Package 2 also takes a dependency on B 1.0 version. You can see here that package C actually takes a dependency on 2.0 version of B, not the 1.0 version. So there are like three copies of B where we can dedupe a couple of them, like B at 1.0 version, but still retain to ensure that C kind of takes a dependency on the 2.0 version of package B, right? So leveraging the node module resolution algorithm, you can see that now if we kind of install all these node packages or dependencies at the at a higher level of the monorepo folder, you can see that if you have these packages under a node modules folder, like you have A, B, C, and C taking a dependency internally on B2.0 under the node modules folder. Also, you can see that there are symlinks created to package one and two, so that say if package three later on takes a dependency on package one, it can still be resolved with the node module resolution algorithm. This concept is called package hoisting. This is really great because this means that we can now have some tools which can help us achieve package management a lot easier, right? Some of the tools that you can use for managing packages in your monorepo are Rush.js. This is something that Microsoft open sourced long back. We also have Yarn workspaces. You can also use PNPM workspaces. You can use a tool called Learner. So in our monorepo, we use Yarn workspaces. Let's just see how it works, right? To use Yarn workspaces, you add a package.json in the Monorepo root folder. You can set private to true, add a configuration around what packages need to be managed by workspaces. You can also use like a regex pattern for having all packages under a certain folder so that like you can continue adding new packages and you don't have to change this configuration. Additionally, you can also have like a no hoist configuration. Say if you have some packages where you don't want to hoist them to the monorepo root level, you can exclude them from hoisting. And then all you need to do is run yarn from the root of the monorepo. So the package installation time for I mean, we use 150 plus packages. So this actually came down from 20 minutes that we used to struggle before to 6 minutes. So this really improved a lot of developer productivity time, right? Uh, the next aspect that we'll look at is how to orchestrate actions or commands across packages in a monorepo. Some of the popular tools to achieve this are Rush.js again. You have Learner. You can also use task runners like Gulp. You can also, if your monorepo is simple enough, you can even manage it with simple shell scripts, right? We need these tools to perform operations across packages, usually from the root folder of the monorepo. So we use Lerna in our monorepo. You can just look at how insane the logo of Lerna is. It's just quite mental, right? Uh, so for using Lerna, what you need to do is add a lerna.json configuration file in the root of your monorepo, right? So that like you can actually start running scripts from the root folder itself. You can add what packages to run your commands in, and then you can specify which npm client you use. In our case, we are using Yarn, so we just add Yarn. You can also add the configuration of use workspaces to true if you're using Yarn workspaces. So this is optional. So if you're not using a Yarn workspace or PNPM workspaces, you can actually set it to false. So that way, if you set it to true, the advantage that you get is Lerna, whenever it's trying to run the commands, it kind of leverages the workspace's dependency resolution a lot easier, right? So what Learner does is it automatically figures out the dependency tree. If there are some packages which require which take a dependency on other local packages, so which means that if you're running a build command, then it will require the build command to be run in other local packages first, and then a certain package. So this way, it executes the commands for the packages in a certain order of the dependency tree, right? So all you have to do is then learner run and then the script name, which can be run across all the packages, right? Let's see an example of how we can use learner. So here I have a TypeScript repo of 4 packages, A, B, C, and D. Simple packages, nothing complicated. It's just a sample that I've just written. They all have similar set of scripts in their package.json. Here you can see that there are some scripts like prepare, watch, uh, run the build, use webpack, and so on. You can also see that here package A takes a dependency on B and C internally, right? Uh, Now, if we run learner and watch in a parallel mode, you can see the order in which the commands get executed, right? So it actually first ensures that it executes the watch command on C and B packages first, and then it runs the watch command on the package A because A takes a dependency on B and C. And we need to ensure that B and C are compiled first, and then you can run and like watch on the files in the package A. So this really solves a lot of pain if we need to execute some commands in a certain order. And this actually saves a lot of time for us, right? One of the other things I really love about Lerna is the scoping feature. In our Monorepo, we use different test dev apps for each of the experiences, like search people. So I work for the project search. So what I need to do is I need to just run commands or watch on the code for all the packages that mainly pertain to search components, right? I don't have to really execute or watch on components that are in people experiences if I don't have any dependency on them. So, so this way it actually helps us to do quick dev validation uh, during development instead of integrating with different host apps like SharePoint or Office. We just use these test dev apps to quickly validate our code during development. The learner scope command allows you to only consider a certain set of packages instead of the whole monolith, right? So if you define the scope using learner run and give the scope option, and you can give the packages list of packages that you want to scope the command to. So this way, it'll allow you to scope these commands to a certain package. It only executes the command in one subpart of the dependency tree. And this actually was a huge win for developer productivity. Here you can see we scope the command to package C. It only runs for the package C and not for any other package. So that way it actually saves a lot of time for us, right? Uh, some of the other very helpful things that Lerna helps us was to manage versions, to publish packages, to manage releases of these packages really efficiently. So it comes with commands like publish, especially like some commands like diff and changed allow you to closely monitor the changelog between any two releases very easily. Let's look at some of the wins that we got out of Lerna. So Lerna actually helped us bring down our build times by more than 5x. So even our watch times improved so much. And we continuously are trying to improve how we can, like for a developer, how the productivity is always increased, right? Learn also has a very good community adoption, which means it's quite reliable. It is adopted by popular JavaScript monorepos like Babel, React Router, Jest, and many more. Uh, to sum it all up, finally, pick the right tools for your monorepo. If you're going for a JavaScript monorepo, you need not necessarily choose the tools that we've discussed, but based on the complexity of the packages that you have, you can improve the developer experience and ensure that you're picking the right set of tools that are conducive and really useful for your team and something that your team feels comfortable with. For linting unit or functional and perf testing, you can always combine it with tools like Lerna to easily run commands across packages. Additionally, if you're using TypeScript, you should remember to ensure that you manage TypeScript compilation and manage the typings generated properly so that you can leverage IntelliSense, and that also helps in improving developer productivity to basically have good robust code that can come out of the developers. These are some references to all the content that I've talked about in this talk. One of my friends, Vincent, has written a detailed article on how we evolved a large mono repository, right? So you also have links to Rush, Lerna, and Yarn workspaces, so you can go through it and learn more about them. And yeah, so finally, thank you. Thanks a lot. That's all in the talk. Thank you very much. I really hope this was very helpful for you. You can reach out to me on Twitter if you have any questions or perhaps the live Q&A that might follow now. So reach out to me at Jason on Twitter anytime. Right? Thank you. Thank you so much. Hope you enjoyed the talk. Have a wonderful conference.